This presentation is for the Wrens, which is made up of Gia, Maddie, and Andrew. So our initial attempts consisted of trying several of the classifiers that we used in the first exercise of this class, using the default settings on Weka to see if any of them had significantly better results than the other. As you can see in the table, they all had very similar results, so our next step was to try manipulating the settings and some of the details of these classifiers to see if we could significantly improve the results of an individual classifier. One example that you can see a bit of in the table is that we tried increasing the KNN value for the IBK algorithm, but this was a bit misleading because the first increase from KNN equals 1 to KNN equals 2 improved the accuracy, but all further increases actually decreased the accuracy, so this was not actually useful. Now we decided to focus primarily on the J48 algorithm because it allowed us to visualize the algorithms and how the predictions were being made. So as you can see in this screenshot, originally only 3 of the 12 attributes were actually being used to create a prediction. Most important of these being the sex, where all female passengers were being predicted to have survived. We noticed that if you look through the data, this is largely untrue for women who paid a low fare, versus women who paid a higher fare were much more likely to survive. So we tried a couple changes to try and get the algorithm to be more accurate, but also to use more of the attributes in doing so. The first thing that we tried was increasing the confidence factor setting so that the tree would not be pruned so much. And we got the tree that you see on your right when we changed the confidence factor from 0.25 to 0.5, which did increase the accuracy, but obviously that's a completely illegible tree, and it has about 1 leaf node for every unique ticket number. So next we did some feature engineering. Since ticket number seemed to be very unique and it had no noticeable pattern, we decided to remove that column and see how that affected the results, since it was being used previously in the tree, but clearly that using that ticket number to predict survival was overfitting to the training data. Without the ticket number, we got this tree. Now, it's still a fairly large tree, but it's obviously much more readable, and it still increased the accuracy just as much. A few other changes that we tried were splitting the name attribute into a first and last name column, and that was to see if there was a pattern for people with specific last names being more likely to survive. However, this resulted in no improvement. And next we tried the discretize filter to split the fares. Since the fares were a continuous number, we discretize broke them into several categories, essentially high, medium, and low, but a few more categories than that. This did not seem to improve the results. In fact, at first it didn't do anything, and then after removing ticket number, it actually made the results slightly worse. So we did not keep this change. So to recap, the J48, naive Bayes, and IBK classifiers all achieved very similar results when using the default settings. Raising the KNN once for the IBK method improved accuracy slightly, but every change after that made the accuracy worse. Raising the J48 confidence factor improved the accuracy, but resulted in obvious overfitting and an exceedingly complex decision tree. After removing the ticket number attribute, however, we achieved an improved accuracy while also providing a usable and readable decision tree. And therefore, that is our best method. And using that method with a confidence factor of 0.25, we achieved an accuracy of 80.02%. Thank you.